Hi everybody, and welcome back to our third video in the ongoing series of changing motion physics tutorials. Here's a story. After visiting with the D block class today, Friday, and trying this experiment for the first time, it looked like some guys were getting some pretty good results from looking at video and figuring out physics for themselves. What I wanted to do to offer one piece more of support had to do with how your homework should look, because I noticed that in following through that it wasn't really clear that people knew what I was looking for. So what I'm going to do is work through a few problems just like they should look on your homework. And picking up with where we left off, let's grab a pencil tool and stop wiggling that thing around. Picking up where we left off, I worked out problems 1 and 2 for you on the last video that you looked at. And what I'm going to do is make a point of going through number 3, but I'm going to do it in a way that it should look on your homework. So here's the deal. In question number 3, if you have A-20 in front of you, that would be a good idea too, by the way. We've got a ball falling for 2 seconds, and you want to know how fast is it going to be going afterwards. So there's not a lot of words, but there actually is a pretty fair amount of physics going on. In this question right here, I've got 4 variables that are going to be useful to me. There's an initial velocity, that's v1, and they tell us that it's dropped from rest, so I'm going to put in 0 meters per second for that part. v2, that's going to be our question mark, because they say how fast will the ball be going. Acceleration, well, they don't tell me, but we did just talk about it in the previous question, that the acceleration of objects, whether they're Felix Baumgartner or whether they're a ball bearing, they accelerate the same way, at minus around 10 meters per second per second. And then the time to give us was 2 seconds. So, as we said in class before, you don't have to write all that stuff out. There are 2 things you do have to write out, though. You have to use some algebra, so you've got to tell people what formula it is you're using. And in this case, we're going to do this. We're going to write out that formula. You have to solve it. So, in order to get at V2, what I'm actually going to do is take the fact that I know that, and I know that, and I'm going to solve the formula and tell everybody that, hey, delta V equals A times delta T. And then I'm going to plug in some numbers. So the 2 things are, you have to have a solved formula, and you have to show people how you're getting your answer rather than just come up with answers. So acceleration is minus 10 meters per second per second. Put that in there. T is 2 seconds. And we get a final answer that my change in velocity is minus 20 meters per second. So the story is that if I started with 0 meters per second, and I change it by minus 20 meters per second, my final velocity has got to be minus 20 meters per second. Okay, so anyway, that's an indication of how much work you should be showing on your homework. So we'll go through this one and a couple more. And we're here. Next question looks like this. In this one we've got a toboggan load full of kids, and what they ask us is if these kids accelerate from rest, and there's that word again, from rest, at a rate of 2 meters per second, and again, there's that tip-off. If you see that unit right there, that always indicates that you're looking at an acceleration. So the question is, how long will it take these kids to speed up from 0 to highway speed, or about 55 miles an hour? And the problem gives you the fact that the second speed is 24.4 meters per second. So, again, we're working with this formula, A equals delta V over delta T, but it looks to me like we're going to have to do a little bit more algebra in order to get that solved formula. So I cross multiply. I've got A times delta T equals delta V, and then we're going to do one more step, and that's divide both sides by A to end up with delta T equals delta V over A. Okay, so what does your homework have to have? Your homework has to have that. Now, you want to show me the work that it took to get through there? That's fine. I have no objection there at all. Thing 2 your homework's got to have is that showing me where you plugged in. So change in velocity is V2 minus V1, so 24.4 meters per second minus 0 meters per second, all over 2 meters per second, and then freaky fact of physics, meters per second divided by meters per second cancels, And dividing by something twice, actually, if you remember, it makes it invert and flip to the top. So I end up with 12.2 seconds worth of time that it takes for these kids to get up to highway speed. Okay, fair enough. And there you go for number 4. And now for our last question. We've got question number 5, in which a hockey player has a pretty sudden change in speed where he's checked into the boards. So to me, 10 meters per second might mean 10 meters per second going to the right, and it doesn't really say so, but there's a plus sign on that 10. And then when they say minus 5 meters per second, you ought to know by now that what that means is that there's a change in velocity, and that's actually the direction part that's changed too. And this guy is now going to head back in the opposite direction. So the story is, we've got a V1 of 10 meters per second, a V2 of minus 5 meters per second. We've got an acceleration that we don't know, and they tell us that this whole thing takes place over 1/2 of a second. So, how should your homework look? Well, you can, again, write that stuff if you want to. Pretty soon you're going to want to. But for now, if you don't need to, great. I am going to write down, because I want to be clear with my audience, the formula that we're working with, and I want to do any algebra that I need to. And what's awesome about this one is the amount of algebra needed is 0. I can leave that formula exactly the way it is, and I can just plug right into it. And remember that delta V is V2 minus V1. So I have minus 5 minus 10 meters per second, and delta T is 0.5 seconds. And so the story is, this turns out to be minus 30 meters per second per second. And the very last thing that the question asks us is, how many G's is this? And it does say that 1G, here we go, 1G equals 10 meters per second. And so if you have an acceleration of 30 meters per second, that is also known as 3 G's. So no mystery there. And so that's it for this time. So we'll see you again real soon, and have a good week. Bye-bye.